Before we begin rearranging equations, we must first take a look at what an equation really is, as understanding this part is fundamental to understanding this key part of maths. Okay, so some boring stuff first. The definition of an equation is statement that the value of two mathematical expressions are equal, indicated by the sign equals. So, breaking this down, a mathematical expression is very much just like writing, where often a value cannot be worked out from. This includes things like 2x, 7, 5x plus 3. All these things have some meaning, but the real maths begins where you put an equal sign next to these. Take 2x equals 7 as an example. We can work out that x is going to be half of 7, therefore x is equal to 3.5. All in all, equations have an equal sign. Therefore their value can be worked out, just like in our previous example, unlike some mathematical expressions. And that's a little understanding out of the way. Another part, which we should look into, is that the expressions are equal. If I was to say 5 equals 5, you tell me that that's stating the obvious, which it is. But that is what an equation is. 5 equals 5 is no different from x equals 5, because both sides of the equation are the exact same. X is 5, 5 is x. Just like 5 is equal to 5. That was a very over-the-top explanation, but it really makes you think about how equations are just expressions, which have the exact same value. This can get really handy when you have equations with variables on both sides, such as x plus 5 equals 2x minus 1, and so on. But now, how do we actually work out these missing variables? How do we go from an equation like x plus 5 equals 2x minus 1 to getting that value of x? The key comes back to the two sides being exactly the same. They are equal. This means that the same action can be done on each side and the equation will remain equal. For example, adding 1 to each side, or taking 2 away, or multiplying by 103. Doing the same thing to both sides will result in the equation remaining equal. And this is the key to solving equations. Take 5 equals 5 again. If you add 1 to each side, what you are doing is 5 plus 1 is equal to 5 plus 1, giving you the new equation 6 equals 6, where we maintain that equality in the equation. So you can see how this can expand to solving many more and more complicated equations. I know that was very long-winded, but I feel it is important for you to understand everything I just said before we move on to actually solving equations. With that in mind, let's actually solve an equation. Take 3x equals 12, a very simple one to start with. We want the end result to be x equals a number. We don't know what number, but a number. So what we have to do is get rid of anything next to that x variable, because we want it to be alone. In this case, the 3 is next to the x value. What the 3 is telling us is that there are 3 lots of x that are going to be equal to 12. To get rid of the 3, we do the opposite operation. In this case, the 3 is being multiplied by x, so we're going to divide by 3 on both sides. Again, coming back to the same thing, both sides rule. If we do this, the equation looks something like 3 over 3x is equal to 12 over 3. And it is good to show this stage of working, so you don't get lost later on. Tidying both sides up, you end up with x equals 4, and that is the answer. Let's look at more complicated ones. For example, 2x plus 5 is equal to x plus 7. Here we have x on either side of the equation, which means we are going to have to do something about it. So we want the answer to be x equals a number again. So, first thing I'm going to do is take the x from the right side and move it to the left side. And take this term move very loosely, as we aren't actually moving numbers around. We are doing operations to allow us to take parts of the equation from one side to the other, hence giving the illusion that we are moving things. But it's a good analogy nonetheless. we need to do the opposite to both sides again, so let's minus x from both sides. This leaves us with 2x plus 5 minus x is equal to x plus 7 minus x, which, tidying up and collecting all like terms, we end up with x plus 5 equals 7. Next to the x, then we have a plus 5 on the left side, which means we have to get rid of that plus 5 again because we want x equals a number. So what we're going to do is we're going to do the opposite of plus 5, which is minus 5, which leaves us with x plus 5 minus 5 is equal to 7 minus 5. Tidying that up, we end up with x equals 2. You can literally apply these techniques to any equation and solve it. No matter how complicated they are, they usually boil down to these techniques, the ones shown in the video. Anyways, thank you so much for watching, and please, if you enjoyed the video, share it out with some friends, and please have a look at my website in the description and on the screen. And if you'd like some extra help at maths or computer science or anything else, please contact me for private one-to-one tuition. Anyways, thank you so much for watching, and I will see you in the next one.